All right, welcome everyone. You've made it all the way to day 2 of crowd computing. So welcome. One of the things I like to do in the class is at the beginning of each lecture kind of talk about either kind of news around crowd programming or introduce you to different elements or different services around crowd computing that will be useful to know but we might not otherwise cover. So today, better know a crowd platform. The crowd platform of the day is Upwork. Anyone heard of Upwork? No? A couple people? Felicia, well, Upwork, okay. Upwork is this great platform that differs from Mechanical Turk, which you're starting to see more of in this class, in that it's a place where you can find experts. And it's not just for crowd work of very short duration, of low expertise or unknown expertise. It's for finding workers where they have some advertised expertise. So if you want somebody who's a graphic designer, you can go on Upwork and you can hire them to do a graphic design job for you. You can hire programmers. You can hire programmers with very specific niche skills. That's one of the ways that I've used Upwork in the past. You go on Upwork, and if you find somebody just to, we were building this smartwatch application, right? And we had all the back end working, and we kind of knew what the user interface we wanted to build for it should look like. But we had not done smartwatch application development before, and so we were able to find someone pretty quickly on Upwork who already had that skill, and so it was pretty easy for them to do that part of it, and we were able to get our smartwatch application running pretty quickly by leveraging that skill from an Upwork worker up there. So Upwork is just a fun platform. You might go on there and see what kind of job. You might offer your own skills for sale on Upwork. You're all gaining expertise here at CMU, and so you may find there's an opportunity to make some money on the side with Upwork. So let's see. So today, the to-dos. So you have some to-dos. So Project 1, we can talk a little bit more about Project 1 today, but Project 1 is officially out and due, I believe, in a week and a half or so. And how many people remember to read the readings and post a slide? I saw about 21 slides, and I think that means there's probably like 10 people who didn't do it. Okay, that's fine for this time. If you haven't done it, please go post your slide in the next couple of days. That's okay this time. So got a couple questions about what those slides should have in them. The idea is basically you don't have to write a lot. It's basically kind of read one of the readings. Well, read all the readings, but then take one of the readings and pick something out of that reading that you would like, that you thought was interesting, or make a connection to something else, or make a point that maybe connects the readings. So something that demonstrates not just a summary of the reading, but something that you thought about or it came to your head while you were reading it. Let's see. So a few other things. So remember, keep up with the schedule. The schedule has the readings on it, so that's where you find those readings. Also has the link to the folder, the Google Drive folder where the shared slide decks for each day are. Sign up to be a Mechanical Turk worker. So as part of Project 1, you're going to earn $2 on Mechanical Turk. But to do that, you have to have signed up on Mechanical Turk as a worker. It turns out that this is fraught with peril. So signing up to be a Mechanical Turk worker requires Amazon to approve you. There's some kind of mysterious process that happens behind the scenes where they decide whether or not you are worthy. And I'm not really sure what it is. If you sign up and you get denied, I'd like to know a few things. So I have some guesses about why this happens, but I don't have the data yet to know why it happens. So a couple of things. So it would be great if you could send me, just informally, and I'll try to collect this, whether you've had an Amazon account before, or if there's a new Amazon account, whether you're a US citizen, or maybe where you're a citizen of, if you feel comfortable with that. And then, do you have an Amazon Payments account already set up? And if you do you have a bank account connected with it? I think those are some of the variables that play into this. But anyway, it will be fun to see what happens. But do it as soon as you can. Fortunately, we don't have to. You don't get out of the assignment if you can't get approved, because everyone will get approved, because I found the person at Amazon who can approve all of you, even if you get rejected. So Amazon is actually very interested in classes like this. Mechanical Turk team is very interested in classes like this. Training up a next generation of people who might use Mechanical Turk as part of applications, training up a skilled workforce who might actually use Mechanical Turk as workers. And so they are willing to go through and just manually make sure that everyone in the course is approved, but that means you have to tell me your Amazon ID. So that is usually an email address, and I'll ask for that. I have a form to collect that in just a little bit. But you all get approved, so that's good. In past classes, we've had to do all kinds of crazy things, like if you don't get approved, try to have your friends sign up, and then maybe earn $2 for them, or then I gave my account to a few people, and then I kind of was like, okay, that's great, but you got some of your hits weren't approved, and that like decreases my rating. So, but on the other hand, I got a couple bucks, so it's okay. Anyway, so do that as soon as you can. This is the wrong date. That is not. It's I think it's on the web page, but I think it's a week from this coming Monday, right? We'll check that in 1 second. So today in class, we're going to have some more examples of crowd computing. So we went through a bunch of cool things that have been possible with crowd computing in the past, and we're going to finish that up. We're going to talk a little bit about why this is different, because I think it's really easy to get into this frame of mind that I'm hopefully setting you up for, which is, wow, this is really cool, like bringing people into computing and kind of combining them and doing these new things. But in some ways, I mean, this is basically what computing has always been. This has always been the story of technology, where it's not just been technology all by itself isolated. It's been people working with technology, to get things done. So we'll talk a little bit about, well, why is this different? And we'll probably start, or maybe we'll start diving into a little bit of how you might think about the different terms that are used in this area. So crowd computing, crowdsourcing, human computation, lots of different terms that are all kind of conflated, and we'll start to try to tease out what those different things mean. That's today. But before we do that, we have a shout key for you, and it is your very first quiz. So if you go to shoutkey.com/proceed, I hope it shows up. Actually, do log in quickly, because I set up the shout key for 1 hour at 2:16, so you have about 6 minutes before the shout key stops working. And this will ask you for your Amazon ID, so if you know that, please put it in. What's that?
What's the pseudonym for?
Oh yes, okay, there's a pseudonym. So remember how there was these points that you'll get? I don't want to use your actual Andrew ID for reporting your points out. So we'll use a pseudonym. So just pick some name that you will remember that is unlikely to collide with someone else's name, and that you don't use like a password, because it might be public at some point. So use Bunny Rabbit 32 or something would be a good one. Yeah.
I don't have an Amazon ID yet.
Okay, just put none yet.
Okay.
Yeah.
By Amazon ID, we mean the worker ID, or just there's a mechanical?
Oh, just that's a good question. I actually don't. I think either your Amazon ID, which like your email address or whatever, associated with account, or probably also your worker ID. So the 8-digit.
Yeah, it's possible.
Or 12.
Yeah.
Yeah. Either one of those. We'll say either one of those. We'll see. We might have to iterate on this. I've not done this before, but I just confirmed last night that we should be able to get everyone online or onto Mechanical Turk. Three responses. Some people are very quick.
So we have 2 minutes?
Oh, no, I just said we had 3 responses so far.
Oh, okay. Sorry, how long do we have?
How about, I don't know, 2-3 minutes. This shouldn't take, not going to spend too long on it. We'll say maybe 3:15, 3:12 now.
So is that our assigned seating from the first day?
It's not your assigned seating, but you know the amazing thing, part of the reason I brought it up is it's always interesting to see, despite the fact that there's no assigned seating, how everyone sits in roughly the same seat. Some changes though. Yeah, this is good. Actually, you guys moved around a little bit more than classes normally do. "13 responses. Well, I guess maybe I should open this up again. I think there's at least a few new people. We had this great activity. Well, I think it was great. Yeah.
I could be wrong. Did you mention that we could also we could discuss about the quizzes as long as we don't like write what we discuss or something? I don't know.
Oh, the quizzes? No. Quizzes should be done on your own in class.
Just by your own, just making sure.
Yeah. Oops. Forgot to confirm that I'm a human. And that broke. So if you'd like to add yourself to the class photo, you can do that here. I guess you'd have to kind of copy and paste a picture of yourself on top of the picture. That's not too hard. Look, I'll pretend I'm in there. Let's see. Picture of myself. Images. Jeffrey Bigham. There I am. Copy and paste myself. There I am. Hey, look at that. That's pretty easy. Copy and paste. No one's named Jeff, right? I just copy and paste that, but no. I'll copy and paste Nathan over here. There we go. See, that was relatively. All right, so it's 3:15, so I'll assume roughly pencils down. Pencils down. 29 responses, that's about how many people are in the room? Something like that. 30 responses. Okay, well, let's look at the responses. So we'll cut it at 3:16. Something like 3:16. Let's not look at this one. Okay, let's look at Amazon ID. All right, how long did Jeff work on Mechanical Turk in the reading? The crowd got the right answer here. 4 hours. Spent half a day's work on Mechanical Turk. Approximately how much did I make per hour? Answer was $5. Yep, $5. How much I made? Crowd got that one right. So according to the other article that we read, when do firms make sense, right? So when does having kind of a firm and kind of the bureaucracy of a firm make sense? And the crowd got that one right too. You know, when purchasing a service is more expensive than organizing it in-house, right? So this relates to crowd computing because increasingly the transaction costs are lower so that it makes more sense to flexibly hire someone outside of your company, outside of your firm, instead of kind of building that expertise in-house. But the idea, just like with Upwork, as I mentioned, with me going off for that little bit of expertise that I didn't have about building smartwatch applications, it made sense for me to recruit that outside of our organization here at CMU because we didn't have that. So it was more expensive to develop it in-house, or organize that expertise in-house, than it was to go outside. And increased connectivity lowers the transaction costs of finding people to do stuff. And that's really kind of what what is driving a lot of these innovations, right? So crowd computing, gig economy, crowdsourcing, human computation, all of this stuff is enabled by connectivity. So the fact that we are more and more connected with each other means that the transaction costs of finding someone who you didn't know before who could do a bit of work for you is much lower, which allows for these things. Any questions at this point? Any questions? Anyone else add their face? No? All right, let's go to the webpage. So one of the things I'm doing this year as an experiment is I'm recording myself give these, oh yeah, there's a question back there.
I have a question about the quizzes.
Yeah, sure.
Are they graded like points wise?
They will be, I think there is a amount of points that is listed per quiz. Just a percentage of the questions, right? Yeah. So there's four meaningful questions on this quiz, and yeah, so you'll get roughly, quarter credit for each question, right? Yeah. So as an experiment, I am recording these lectures. So there is a link now on the webpage. So if you weren't here before, the webpage is programthecrowd.com. And so you could, if you wanted to, go back and watch all of lecture 1 again. Or if I say something in a later class that contradicts something that I said earlier, like if I say later that, I don't know, grading is much harsher than what I just explained, you could go back and find that, and you could show that in fact you said that. So they'll be up there. I'm going to post these as we go. And if you miss a class, you might want to watch. Okay. Back to, oh wow. I feel like we stopped somewhere right here. Is this right? Crowdsourcing in industry, maybe. So we had talked about all these crowd-powered systems. We talked about kind of cool applications. We talked about Greg Little's experiment with his messy handwriting and how he was able to recover what was written. And so now let's talk about how this might be making its way out into industry. And so this is a little, I guess, glib, but in some ways, if something seems smart, so if some technology product out there seems smart, probably there's some crowdsourcing involved somewhere in it. And we see this a lot in all kinds of different things. There's this great example. This is Panos Iporotis, who's at NYU's business school. One of the things he did as a collaboration with industry is he worked with Zappos, I believe it was Zappos, and he had the crowd fix reviews on Zappos.com. And one of the things he showed, which is pretty amazing, is that people were more likely to buy a product if the reviews had proper grammar, if they were written well, irregardless of whether the reviews were positive or negative, right? Just fixing the grammar, making it seem as though I guess people who write well bought this thing, increased sales, which is kind of cool. So a kind of unintuitive use in industry. Google Maps, there's this link, you can follow this link to find out more, but Google Maps and now the other mapping products out there heavily use the crowd to fix themselves, to add things, to get kind of more real-time information about what's going on in a particular area. And this really came out when the iPhone for a while used Google Maps, and then they switched over to Apple Maps. And when they were released, people were shocked to see how bad the Apple Maps were. Right? There's all these articles about how they just weren't very good, or they missing obvious things, or they would send you down a one-way street the wrong way. And how did they do that, right? Weren't they using the same mapping data that Google got? But it turned out that Google started with generally available mapping data, but then they had this huge crowdsourcing operation, both in-house people and then increasingly people out in the world. So as you use Google Maps will ask you things, right? And so it improved itself in that way. And so it seemed so much smarter, so much better, and it's because they improved it with people's input. And of course now Google bought Waze, but Waze really pioneered this whole idea that not only using the crowd to kind of fix the static maps, but to observe the real-time conditions on the roads, right? So the idea that you could not just kind of know how to get someplace, but know how to get someplace right now, right? So if a particular road was backed up because there's a lot of traffic or it's a traffic accident, Waze could monitor that because it would send kind of the real-time information about how cars were making their way through the highways back to the servers at Waze, so that it could then inform other people. Well, you might not want to go that way because right now it's backed up. I remember Waze sometimes will sometimes tell you to do crazy things that often will end up being faster. So I was in Boston once. I was on the highway in the middle of rush hour for some reason. I think I was trying to get to the airport, and Waze told me to get off the highway, but then go right back on. So get off the off ramp and then just basically get right back on. But it turned out that was faster because the off ramp was much less crowded than the highway, right? And so the off ramp was pretty long. So probably it had observed somebody do that, or maybe it observed two different people, someone doing the first half and someone doing the second half, and saw that it would be faster to do that. I turn, even here in Pittsburgh's kind of crazy with traffic. There's various places that get clogged, and it's hard to predict. Tunnels close, all kinds of things. And so I'll often keep the GPS on, right? Because the GPS has the real-time crowdsourced feedback to tell me which way I should go right now, even if I know how to get somewhere. This really confuses my parents, right? My parents are like, don't you live here? But yeah, anyway. People heard of Facebook M, or there's other kind of similar services now, like Magic and a lot of different startups. But the idea here is that there are conversational assistants that are built into our technology. Siri on the iPhone, Alexa, or I guess Alexa and Cortana are kind of like one thing now. Did you hear that? Was news today. Anyway, but they're pretty limited. I think I talked a little bit about how they're kind of limited. They're especially speech command-based rather than conversational. And so a number of different companies have explored the idea of, well, what if you had people behind these systems? And so Facebook M is an example of this, where they have people behind the scenes that are helping to answer the questions that come in, and have a real conversation with people. It tends to be that Facebook M mostly targets, and most of these products so far target kind of higher end conversations. So where the end goal is usually purchasing something of some sort of value, right? So they might help you, say, purchase tickets for an event or something like that. But you could imagine kind of pushing that down so that you could build an assistant that uses the server approach for all kinds of things. Yeah, so I guess that's my end of examples of crowd computing, but we'll see a bunch more in the class. And so let's talk a little bit about, what connects these ideas. And I think really we started with this last class, but really the idea is connecting people with computational means to get things done. We also talked a little bit about how this impacts the future of work, and how crowd work kind of drives AI. How do we make this a positive thing so we're not just replacing jobs? But I promised to talk about what makes this new, right? Because to some degree this has always been happening, right? So Facebook M is kind of cool when it's positioned, if you think of it as an alternative to, say, like Siri. But Facebook M is really kind of like a concierge service, right? Or when I tweet to Delta Airlines, which I do a lot because I travel a lot, they don't pretend that, and they don't want people to think that there are robots answering. It's just people out there. They have essentially a call center, right? So what's really the difference, right? If I used to call a call center, how is that different than some of these things? Or people working with technology throughout history, is that really too much different than what's happening now? So it's probably not too surprising that people can do amazing things, right? Here's an example of an amazing thing that I like. This is Pig in Boots. It's getting a little old, but still has a special place in my heart. And so it's not so surprising that people can do amazing things. They come up with amazing things. They're creative, and so it's probably shouldn't be too surprising that we would like our computing systems to kind of emulate human behavior. And one way to do that is just to bring them into the loop. And to some degree, it's really not new, right? So here's a short video we're going to watch about the first human computers. I hope. Set audio.
Space station. We've made calculations with increasing efficiency and accuracy. Today, the work is done by computers.
Computer, no. A programmable high-speed electronic machine that performs mathematical or logical calculations.
In the past, the work was done by human computers.
That's a long time ago because of the music.
One who computes, a reckoner, a calculator.
Intrigued by accounts of Halley's Comet, French astronomer Alexis Claude Clairaut set out to compute the date of its return. He divided the problem into parts, and with the help of two colleagues, rushed to complete the calculation before the comet's return. The result was surprisingly accurate for its day, and one of the earliest examples of people collaborating to perform complex computations. The march of human computing accelerated in the Industrial Revolution. The new strategies of mass production, division of labor, and manager supervision that were transforming manufacturing were also effective in computing. Complex calculations, divided into simple parts, computed by teams of laborers with basic math skills, meant fast results. Computing opportunities now opened to women, because they were skilled, but also because mass production depended upon their cheaper labor. During the Great Depression, the WPA took an interest in computing and created work for the unemployed.
In the winter of 1937-38, they needed more jobs. One of the Washington, D.C. officers suggested that they put together a computing group. They structured this office following a classic model. At the top of the structure were a few scientists. Beneath them, a group of planners. Underneath the planners, there were 450 workers who did the actual computation. The group lasted for a decade. It actually survived the demise of the WPA itself.
The Mathematical Tables Project completed 28 volumes of calculations that enabled advances in science, engineering, and industry. World War II. Men were sent to battle, and women were again in demand as computers, this time performing the calculations of war. In 1945, 6 of these women trained to program a groundbreaking electronic machine that calculated artillery shell trajectories, the ENIAC. Setting up a problem for computation on the ENIAC took several days. The ENIAC women simplified the process by using a method to store programs.
Then you never had to set up the machine again. All you had to do was to set the switches and the function circles. So the horrendous problem of programming the ENIAC was gone.
Today, the ENIAC women are recognized as pioneers of computer programming. The final grand project of human computers, 10 years in the making, was the Handbook of Mathematical Functions. 1,000 pages of computing formulas and tables, including many from the WPA Mathematical Tables Project. Published in 1964, it was a valuable tool for 20 years. But it debuted the same year as this computer, a huge leap forward in powerful mainframe computing. Increasingly replaced by electronic machines, some human computers found work as programmers. Their contribution and legacy will not be forgotten. Some may even say it can't be calculated.
So this video is interesting to me for a number of different reasons. It's clearly talking about a time that's far before what we would maybe think of as kind of the computing age, and it's much before anything we started talking about as human computation or crowd computing or crowdsourcing. And yet a lot of the themes that are addressed here have come up or are still kind of coming up in crowdsourcing today, right? And I'm sure I'll forget some of them, but one is, it's interesting where, at least at the beginning of this video, they said, well, one of the reasons, or one of the things they looked for in a workforce was the fact that it was cheap, right? This is actually, I think, a terrible reason to get into human computation. Most of the interesting work in human computation, crowdsourcing, would be interesting even if it wasn't cheap. And over time, I think things changed. But as it was in the past, this is still heavily mentioned, especially in the early papers, early in this case meaning around 2006 to 2010, in the computer science literature about crowdsourcing, where people talk about how cheap it is. But I think maybe cheap isn't the most interesting part of it. What else did they talk about? They talked about, they talked about eventually the crowd workers, the human computers, realizing that maybe they knew something about this job and they could do it better, right? And that led to some of them doing essentially programming. So programming that wasn't expected. And we're seeing this also with Mechanical Turk, right? Where people think of Mechanical Turk workers as kind of these non-experts, right? But if you really dive into it, there's a whole community around the most active Mechanical Turk workers. They kind of band together. They share strategies about how to work better. And so, it's repeating itself again. It's not just kind of people doing this routine work, just doing it forever. They're actually learning something. They're getting better at it, and they're innovating in how to make it better. Let's see. So one other thing. Well, at least the final thing they said was, eventually these human computers were kind of automated out of their jobs, right? So essentially, especially for these mathematical calculations, once those mathematical calculations could be done in the calculator, on the calculator in your pocket, it didn't make as much sense for them to be doing that work. And interestingly, some of them were kind of able to ride that wave of automation and kind of skill up to the next level. So some of them were able to kind of turn their careers from being human computers into being programmers, but probably some of them weren't, right? And so that's also kind of happening here, right? So, some workers probably will learn or have the skill to, over time, as certain types of work become less available potentially because it's being automated away, they'll be able to transition to other things. Other workers may not. And, not really mentioned here, but there's a lot of structure in there built into how the human computers of the past worked that allowed some people to make it and some people to not make it. And so as we think about how we might change the crowd platforms that we have, the working platforms that we have, you might want to think about, well, how can we structure them so that people are more likely to be able to kind of, ride that wave rather than being overtaken by it. So lots of interesting things there. Let's see. And then I guess the one other thing I forgot to mention is it's surprising how similar the structure, at least in the beginning, the structure of the human computers are to a lot of the work you see in crowdsourcing, right? So, there are these few like fancy scientists or mathematicians or whoever at the top, and then there's just like this massive number of people who are doing relatively routine work. And that may not be a good organization, right? That may actually not be best utilizing everyone. Okay, so turns out, and we've already seen a bit of this, that there's a bunch of different types of crowds. So where are we going to find our crowds? We're going to talk about who makes up the different kinds of crowds that are available. We've seen maybe two in the class already. We've seen Mechanical Turk, which I keep referring to, and then we've seen Upwork, which are very different in different ways, right? So but there's a lot of things that are in between, and that a lot of different kinds of crowd, different kinds of capabilities, different affordances, so things that are easy and hard. I wish, by the way, that this was me in this little computer costume, but fortunately it's not. It's just somebody out on the web who dressed as a computer. Right, and so to me the big thing is connectivity. We've long dreamed of these fancy machines. This is a Memex machine, which was a kind of an envisioned system that would be kind of like the all-knowing internet that you could talk to about anything, and it would help you do your work. And we've thought this whole time we had to build this with just automation, but it turns out we can put people in there, maybe make it work better. So Mechanical Turk, which I mentioned a few times, is kind of a reference, or its name comes from this original Mechanical Turk, which was a chess-playing automaton, but really inside the cabinet was a person. And so this toured first Europe and then the United States, I think in the early 1900s. And so it's kind of a reference to, and people thought this was like an amazing invention, and it turns out there's just this amazing person hiding in the box. All right, so many other services, here's just a few of them. We'll talk about those, and as part 2 of your assignment, you get to go find some of these and tell me about them, right? And so one of the fascinating things is that they keep coming up. New ones keep getting founded with different kind of capabilities, different focuses, different things that they advertise being good at. The other source of crowds, right, that kind of alluded to is social media, right? So probably all of you are on some kind of social media, and in different ways you can see this through a crowd computing lens, right? So sometimes pretty directly, right? Quora is kind of built for asking questions and kind of getting back the accumulated wisdom of the crowd. Stack Overflow, I don't know how I made it through computer science degree without Stack Overflow, but certainly it's a pretty amazing source for crowdsourcing knowledge. Even Facebook and Twitter, right? Like you can ask questions on them, you can get feedback on things, you can, in different ways, as we'll see, query people on these networks who have particular expertise. One example is, well, it used to be more, back in the Stone Ages of Twitter, when people would share their exact locations on Twitter, you could find people who were in a particular location on Twitter and ask them about that place, right? So people built systems, say, that asked the people who were at the airport how long the TSA wait time was, right? And you could do that back then because it was really easy to see where people were. Another example is games, right? So a lot of times people want to build games. They think, well, I don't really want to pay people to do this work, so I'm going to build a game. And the reason they do this, I think the reason they think this is because, one, they don't have to pay people if that actually worked. And then, there are very popular games online. This is kind of an older slide, but at some time, probably around 2010 or 11, Twitter only had about 20 million users. Farmville, anybody play Farmville? It's kind of getting older game. Nobody? Really? Yeah, see, okay, somebody does. Okay, that's good. Farmville, which was a very popular game for a very short amount of time, had about 80 million users. Maybe today the more appropriate example of the flash in the bucket, flash in the pan game is like Pokemon Go or something. We had a huge number of people. And still there's some people, but and Facebook's way up there. Anyways, there's a huge number of these different sorts of services that connect you to human work in some way or another in different kinds of different areas. So when we think about crowd computing or how we might actually engage with the crowd as scientists, people who want to build things, there's a lot of different questions that come up, right? So how do we choose the right crowd that will help power our application, right? So things like, do we need them to have expertise or not? What sort of credentials do they need? Do we want them to be anonymous or not? How do we track whether they're doing a good job or not? How do we break down the tasks we have people do appropriately, right? So they didn't get into it in that video we watched about the historic crowd or human computers, but they probably weren't just giving people the original question, right? So they were presumably breaking it down into some sort of algorithm, having people perform the steps of that algorithm. And so depending on what we want people to do or what the final outcome we want is, how do we appropriately break down a problem? If we remember that plate mate example, we're taking a picture of food and we were figuring out, well, what's the nutritional content in that plate of food. A big part of the contribution for that system was, how do you break that process down into something where a non-expert from a crowd platform can come and contribute what people can do pretty easily, perceptual parts, and then work with the computer. So how do you break that down into something that people can do? Programming the crowd easily, it may not be obvious. If I take just an algorithm I have running, I have essentially want to make a function call to a person. How does that actually work, right? So how can we build computing systems, programming systems that make it easy to do that sort of thing? A lot of questions there. How do we incentivize quality work, right? So everything becomes harder once you involve people. There's a joke, right? The hardest problem in computer science is people, and then the second hardest problem is convincing people that the hardest problem is people. Once you involve people in this process, it's much less predictable, right? So is the work going to be good? How do you make sure that you get quality work back? And that's both. There's a lot of different ways that we can think about that, which we'll talk about. Making sense of the work you get back, right? So it's not always the case that it's even easy to incorporate things that people send back to you. So in the Turkit example with the sloppy handwriting, there's a lot of kind of iteration that went on before that to just figure out, well, how do you even present this problem to somebody, right? So that future workers can make sense of the partial work that the prior worker did, right? So in their case, they came up with a scheme with parentheses and question marks and different things where they can express confidence in the different words that they wrote. But depending on your problem, that may not work. You might have to come up with something new. So how do you make sense of the work that people did so that you incorporate it into something bigger? How do you choose good problems? What's even a good fit for this sort of approach? And then making crowd work beneficial to workers. So how do we organize all this stuff so that crowd workers benefit from it? So it's not just a one-sided. All right. So what will you take from this course? So this is kind of the conclusion of the introduction. So one is you'll learn a lot about crowdsourcing, related concepts, how they're related, and how they're likely to develop, right? Where is this going? Can we start to build up vocabulary? Can we start to build up kind of a sense of the various trends and what powers them, when this sort of thing works and where it doesn't? I think it's really important, which is often overlooked, is understanding and appreciating this field from the perspective of workers, right? It may not be true for the people in this room, right? You're kind of at this high end and of the expertise level, or you're gearing up for that, right? But many people in the world may have employment that looks a lot more like crowd work than, say, the prior generation did. So these elements of kind of flexible work, which can be good or bad, flexible or unstable work. What does that mean? How can we make sense of it? How can we build tools that work with that well? And so I think understanding that from the worker perspective is important. And then learn to build applications that use the crowd, so use people out on the web to get things done, that collect data for you. So probably many of you are interested in how do you collect data and ensure quality and those sorts of things. How do you build applications that power themselves with the crowd? So we'll talk about how you actually build those things. So, and so another way of kind of summarizing this is, we have advantages here that we're trying to take advantage of, right? So there's a lot of advantages to bringing people into computing systems because we can't do everything we'd like to do automatically yet. So we want to access human intelligence. We want to access kind of collective intelligence. So the idea that sometimes querying a bunch of different people can actually give you better results than just querying one. We want the flexible nature of it, right? I mean, it is actually really nice that, for instance, when I am trying to run a large study with something like Mechanical Turk, I can spin up a study with 10,000 people, over a weekend, and I can pay them for their time they spend, but not have to maintain that workforce all the time, which is different than traditional employment. And we can use all this to train AI, but there's huge challenges that come at this, right? So how do we find people? How do we actually make this sort of thing work, right? Like, how do you incorporate the people's input? How do we structure tasks? How do we create proper incentives for people? How do we think about expertise? Do we need expertise? Do we have to find expertise in our crowd? How do we balance kind of the ease of the API call, right? So being able to access human intelligence at the call of an API is really powerful, but how do we balance that with human needs, right? Turns out that people don't necessarily like being called via an API, right? People want to talk to you. People want to have a relationship, right? And traditional work supplies that. It's another benefit. I should have mentioned one other difference between Upwork and something like Mechanical Turk. Mechanical Turk, I can literally write a program, and there's a function call that goes off and can do a human computation job, and then return the results. Upwork, people want to talk to you on Skype, right, before they start your job. And so, how do you balance these two kind of the benefits of both of these? And then how do you kind of integrate AI and HCOM, right? So I think there's a lot of hype around AI kind of development and how it's going to replace everything and how it's so amazing. But probably, at least for the near, medium, and even a lot of things in the long term, it's really going to be AI working with people. And this domain of human computation, crowdsourcing, is a place where that's really going to start very soon, if it's not already, right? Where a lot of these jobs that people are doing are right at that cusp of what AI can't do, which means they're probably really well positioned to be supported by AI before AI can do it. So we can start to explore those things. All right, so that, I think, is the end of this. Is there any questions? It's kind of like an overview of the course, a bunch of different things. Yeah?
Is there a programming language we'll be using to build our application?
A lot of what we'll do is just web programming, so HTML, CSS, and JavaScript. And part of that is because so much of what we're going to be doing is more or less building systems and interfaces that people need to use, and those people are remote to us, and so a convenient way to do that is to build a web page. And so that's a lot of where the interaction happens. Anything else? No? Okay. Let's see. Oh, I guess there's a bunch of stuff down there. All right, so let's talk about some of the various terms. I don't think we'll get through all of this, which is fine. Let's talk about some different terms that can be all used. Oh, there's somebody else there. That's cool. So much fun. In this whole crowd computing area. One of the reasons I use crowd computing is this. As far as I can tell, although it does appear online some places, it's not one of the terms that's commonly used, and so it's kind of vague enough that hopefully people don't have a preconceived notion of what that means. So some definition, let's see. So people, what are the people that we are going to be talking about called? For simplicity and clarity, it's often useful to differentiate the people who are kind of requesting the work, so the requester, and the people who are doing the work, so the worker. So requester, individuals or group for whom work is done or to take responsibility to aggregate work, and the worker, someone who contributes to a job. Anyone have an idea of like where that doesn't actually make sense? Where is there somebody that doesn't fit this? Yeah.
The middleman, so I'm these two.
Yeah, sometimes there are people in between, right? So it doesn't happen as much as it could on a lot of the crowd platforms that we use, but you could imagine somebody who's kind of like the manager of some crowd workers who is basically responsible for pairing workers with requesters. That makes sense? This happens a lot on Upwork. There's kind of these like organizations, so people will list themselves as the contact, but they actually have all of these workers who kind of work under them, right? But it's a convenient way. They have like a little small business. Surprisingly, it even happened on Mechanical Turk, which makes almost no sense to me, but it definitely happens where people have what I think are more like guilds, where They're a group of workers who kind of know each other, talk to each other, work together. So one time I posted a fairly large job on Mechanical Turk, and I got contacted by someone who said that he didn't use the word guild, but him and his group, they would really like to do my jobs. Could they have like exclusive access, and they would guarantee quality. So they were basically trying to put an add-on service on top of Mechanical Turk, where it is a big problem that quality on especially Mechanical Turk is sometimes hard to achieve. You don't know exactly what you're getting, and so they were doing it informally, right, with their group of friends. Another place this comes up is where the workers themselves are kind of directing the crowdsourcing project, right? So this is something like, Wikipedia is crowdsourced, but it doesn't cleanly fit into this model of requester and worker, right? So you have kind of the crowd members both doing the work, but also kind of deciding what work needs to be done. Let's see. So another way to think of this is, is this what kind of task are people doing? So the model I just described with requesters and workers, this fits best with this directed model. An individual recruits and guides a group of people to accomplish a goal. That's kind of requester requests, directs, workers work. Can also be other things. So collaborative. This is more like the Wikipedia model, right? Where kind of group comes together and they want to do something, and so they kind of, based on shared interests and goals, they pursue that thing. Another kind of crowdsourcing that doesn't have a clear requester worker breakdown is passive, right? So Waze, for instance, I sign up on Waze, but I don't really ever have to directly do work. You can report various things, and that's maybe kind of directed, but I can just leave the app open. It would collect stuff as I drive around, and I don't really have to ever do anything. So it's kind of passive. Facebook is using passive crowdsourcing all the time to figure out the quality of different posts, figure out what might be spam, what might be abusive, and so you can think of these different terms. Here's one attempt. This is Ben Peterson and Alex Quinn's attempt to put some of these terms into a handy Venn diagram so you can kind of see how they overlap. We'll kind of dissect this a little bit. But some of the terms, like human computation, this is kind of Louis von Ahn's term for people working with computers. Crowdsourcing, social computing, kind of this collective intelligence, and data mining. Let's see. So we already covered this definition of crowdsourcing. Crowdsourcing is the act of job traditionally performed by a designated agent, usually an employee, and outsourcing it to an undefined, generally large group of people in the form of an open call. To me, the most important thing is, as I said last class, the most important thing about this definition is this open call. So the idea that you don't know who is going to be responding from a group. There's some question, if it was Mechanical Turk where there's only a certain pool of workers that are on Mechanical Turk. Is that crowdsourcing? I think so, because there's this group, you put out a job, you don't know who's going to respond. Anybody on the platform can respond. Social computing, so a lot of times we talk about social computing. It's a group here at CMU. And this is kind of maybe related to crowdsourcing because it involves applications and services that facilitate collective action and social interaction online between people. And clearly, to get crowdsourcing, most types of crowdsourcing, you probably have some kind of interaction. I think why these circles aren't completely overlapping, right, is that it doesn't have to be social. You can sign up to Mechanical Turk, you can do some work, you never have to talk to anybody. You can do crowdsourcing. Sorry. And so both of these kind of relate to this idea of collective intelligence, where oftentimes the reason you're trying to get at the input of multiple people is because you're trying to have the kind of individual contributions add up to something more. than just the sum. And so groups working together to seem intelligent. So collective intelligence is this overarching concept where it's not just people even. You can have ants that have collective intelligence, working together. I think there's a video of, not available. Here, this is also, what, it was just there, I saw a picture of it. Well, okay, so what this was a video of a researcher from Princeton who has fish that collectively, based on relatively simple behaviors, do intelligent things, and he basically experiments with these fish to see like what all kinds of intelligent things. Ian Cousin is his name. Swarm intelligence, right? So there's all these kind of variations, right. So we also think about, well, what do we do with all this in data mining and machine learning? So data mining, trying to make sense of a large data set, but most of the really interesting data sets come from people, right? So maybe it's crowdsourced, maybe it's passively crowdsourced, maybe it's directed crowdsourcing, but a lot of these most interesting data sets come from people. And so we're using statistics to figure out what's going on, right? So, and this might be a way, it's not often thought of, but a way of kind of achieving this collective intelligence effect, right? So we have a bunch of people who are all contributing, say, routes to get from here to the airport in Pittsburgh, and maybe our data mining approach is able to make sense of all that data to find kind of the best route to get from here to the Pittsburgh airport. Human computation. So a lot of times people, I think, have used human computation and crowdsourcing relatively interchangeably. I'll try to differentiate them for you. A paradigm for utilizing human processing power to solve problems that computers cannot yet solve. A computational process that involves humans in certain steps. I kind of like the definitions of human computation. These are all taken from papers. Human computation that kind of describe an algorithm in which some of the steps, those steps that maybe the computer can't yet do, are done by people instead. And so maybe that API call is done by people. Yeah?
So in this scenario, is computation like defining a task that has a set of like smaller tasks? Like how do you define computation, I guess is my question.
Oh, how do you define computation? I feel like that's a question I should know. I think, to me, I guess, I'm sure there's a formal definition, but an algorithmic process that goes from an input to an output, right? And for human computation, some of those steps would be done by people. And oftentimes, you could imagine some of those steps eventually being done by the computer, right? So an algorithm that I have sometimes used to kind of illustrate this is imagine you are trying to build a computer system that gives fashion advice, right? You got a picture as input, and you've got this algorithm, it has different steps. Maybe you have some expert knowledge, some database about like, what colors go together or something like this, right? But maybe you can't yet with computer vision extract out like the different kinds of colors and the different parts of clothing that somebody might have. And so maybe you make this function call out, give the picture to the person, and say, give me all the different colors that are on this person who's in the center of this picture's outfit. You get an array back of colors, right? And then you send that off to some automated thing that has the expert knowledge from this table somewhere to say, well, you wore pink and red. Pink and red do not go together, and so this is not stylish, or maybe it is now, I forget. But that's the kind of thing that you would imagine, right? You imagine an algorithm that at some point, most of the steps could probably be automated, right? So you can imagine a computer vision system doing many of those steps, but at least for the time being, you're not having an algorithm do it because people are doing it. And you might imagine there are potentially human computation processes that you would not want to ever automate, right? Because maybe you're seeking opinions about something, right? And it's actually part of the computational process that you're collecting opinions, and the output should reflect real human opinions. Again, kind of just illustrating. This is kind of an old idea. You know, this is a cartoon from a while back. A computer using human brains, just as humans once made computers with mechanical brains. They concentrate on any question I ask them, or I'll shut them off. Kind of a dark way to think about crowdsourcing, but also kind of a reflection. People have kind of thought about this for a long time, right? You know, you saw the video, you saw this, or we see this now. You know, this idea that somehow people are kind of doing some of the processes, could be doing some of the processes in a formal way that computers do. So the phrase isn't new, but the popularity of that particular phrase is new. So it's the title of Louis von Ahn's dissertation. You know, for a while it seemed like it was a close competition between human computation and crowdsourcing. You had the lead for a little while, but crowdsourcing has kind of pulled ahead. Kind of sounds better for some reason. And so you'll have a couple of readings that I think are for the next class that will dive into these issues more. But it's interesting thinking about how you can, you know, come up with phrases like these that make sense, right? So, what would human computation using crowdsourcing mean, for instance? Well, that could be, well, you've made this computational system. Some of the steps are outsourced to people, but instead of having, say, an employee around who always just services those requests, you just make an open call out to a platform like Mechanical Turk, and that's where the people come from. You can crowdsource on social media, right? So you could ask a question on Facebook. Data mining collective intelligence from the crowd, right? So maybe you make an open call for a bunch of different opinions, you run some machine learning on it, and that somehow allows you to come up with a more reliable answer than you could have gotten if you just asked a few people or one person. So there's definitely differences in these, even though they overlap and often they're used interchangeably. All right, so why did we talk about crowd computing or crowd programming in this course? Oops. And I think it's mostly because, you know, I'm interested in how we can use this to build things, right? So how we're going to build AI systems, how we're going to build applications that use the crowd, etc. All right, so why don't we stop there and then just spend the last 15 minutes of our time together. Your next assignment is going to be doing some work on Mechanical Turk. So I thought I'd give you a quick tour of Mechanical Turk. So Mechanical Turk is at mturk.com. Try to make it bigger here. Log you in. All right, so I've logged in. Fortunately, I've already been approved. And you know, I'm given this big list of jobs that I could potentially do. Let's see. So if I just look at these in order here. Oh, look, my friend Chris Callison-Birch at University of Pennsylvania has a job up here. So this is order Hindi to English translations by their quality. So if I click on that, click on. It'll show me a little preview. The instructions. You know, probably people don't spend a lot of time reading too carefully. It says, sorry, there are no tasks to be done. Please come back later. So I guess even Chris makes some mistakes. But it's also true that if I try to accept it, this is kind of a limitation, one of many limitations you'll see with Mechanical Turk. If I try to accept this hit, it will tell me I am not qualified to accept this hit.
Yeah, you have to speak Hindi.
But how does it know? Oh, because at the beginning there was this link here that could have told me that, hey, you're not actually qualified to do this job. There is a checkbox. This is a handy checkbox just to give you a heads up here. Checkbox, if I click for which I am qualified, and then go, then I'll only get hits that I'm qualified for. You think maybe that would be automatically selected, but it's not. So here are some other things that I can do. If you look at this data about each one of these jobs that are available, so the title is annotate gender, ethnicity, and skin color of a person. Wonder what that's about. It'll tell you when the hit expires, so it expires a while from now. Time allotted, it says 60 minutes. So do you think it's asking me to do 60 minutes in 1 second? So it turns out the time allotted is not actually related, at least not very closely, to how long it is expected to take. Now, they may be severely underpaying. They probably are. Many people do on Mechanical Turk. But those times are normally pretty arbitrary. And it says there's a lot of hits available, though. So a little over 8,000 hits are available. So I could, maybe if I got in the hang of doing this, I could do one after the other after the other. So if you just did 200 of these, you could earn your $2 and your whole assignment would be done. There's probably faster ways, but I think a lot of workers might see something like this and they say, well, okay, so I could probably do something and earn a little bit more money, but then there's this risk involved, right? Like I have to go find those hits, so it's not really clear if it's a good trade-off to do this or not. So I could view it, and I will view it in a second. One browser extension that I have installed is called Turk Opticon, and so this is a browser extension that is kind of a crowdsourced rating of requesters on the crowdsourcing platform Mechanical Turk. So this is by Lily Arani and Six Silverman at UCSD. They made this a few years ago. And so what this allows me to do is I can, this little arrow does not appear on the Mechanical Turk site. And so if I click it though, if I hover over it, I can see various attributes about this particular requester. So apparently they either have a 0 out of 5 for communicativity, or they don't have any ratings, I'm not sure. Generosity, pretty poor, so we might have guessed that by the 1 cent. Maybe not, but they seem pretty fair though, and they're pretty prompt. So promptness is related to how quickly they pay. So I could look maybe this next person. The person got a 1 out of 5 for communicativity. You should try this actually. So when you're doing your work, if you're interested, there's a way for you to contact the requester and just ask them something about their hit and see if they respond. But it does get back to these differences between platforms, right? So Upwork, again, you have to have this conversation with the workers you're employing. Mechanical Turk doesn't enforce it, and so a lot of people don't do it. See if we can find anyone. Oh, that's all kind of the same person. So can we find anyone who, no reviews? Look at there. There's somebody that, well, everything else is bad, but at least they communicate pretty well. Okay, so here we go. Berkeley Dietforst. So pretty good. This is pretty good ratings, right? So you might say, okay, well I should take that, and you can take this 10-minute survey for $1 and a possible 25-cent bonus, right? That's actually pretty good, right? You'd be potentially more than halfway done with your assignment with this 1 10-minute survey, right? And it kind of shows you, right? Like you could have, it's unclear your best strategy at different points, right? Do you just take the jobs that are there? That first person, they're not very communicative and like they probably are way underpaying you, but there's 8,000 jobs to do and you can just click through them and do them, right? At least the risk goes down. Or you could be searching through this interface and maybe you could find something like this, which might be a better paying job. Of course, we don't really know, is this 10-minute survey really a 10-minute survey? How likely are you to get that 25-cent bonus? But it seems plausible. All right, I'm going to do one of these. I'm gonna do one of these jobs here. Let's see how good this shopping guy is. Okay, so I'm gonna do get product codes and prices from receipt image, get bonuses for long receipts. Okay, I'd like to get a bonus for a long receipt. Okay, I'm gonna do this. Here are the instructions: get product codes and prices from receipt, get bonuses of up to 42 cents. Okay, wow, there's a lot of things to do here. Okay. Maybe I should go back to that ethnicity one. Wow. Okay. One of the things that, I guess this person did it right. Another just trick. A lot of times, see how I haven't accepted the hit? But this is just an iframe with a web page on it, and so I could actually start, if the requester hasn't explicitly deactivated the form fields, I could just do these jobs without realizing that I hadn't accepted the hit yet. And so that happens a lot. But okay, let's go back. I'm not going to do this giant form filling one. Sign up for a cognitive experiment. I can sign up. I don't have to do it, I think. Sign up. Oh, accept. See, look, that's kind of nice of them. They say accept the hit first. All right, so I'm going to accept this hit. So at this point, I've said I've reserved this hit to do, but I've not committed myself to doing it. So I can always return it, or I can just not do it and not face a penalty. So there's all these different kind of mechanics of how each of the crowd platforms work. In this case, I've taken this out of the pool, so no other worker can do it until it times out, which is actually what that 60 minutes is. 60 minutes is when this job times out. All right, so I can sign up. What state am I living in? I am living in Pennsylvania. Male. I'm 36. I think I have a PhD. Not race, like white or something. Religion. Okay, so then I can submit. So there, I just earned 25 cents, probably. And I think they did this wrong, because if they actually let me do this again. That's weird. Okay, well you could just sign up for the same experiment 8 times and maybe they'll reject you, but yeah.
For the purposes of like the $2 that we have to come up with, do we have to be approved for the $2 by the deadline, or do we just have to like show you like a screenshot that we got?
So in practice, I'm not going to be too hard on you on any particular thing. At minimum, you should have submitted $2 worth of hits.
Right.
Ideally, you should have been approved for at least some of them. I would not. I guess if you're doing this, I wouldn't count. The bonuses are very unreliable. You never know when that's going to come through, if at all. And you have very little recourse. So part of this is kind of getting experience with those sorts of things, right? So the fact that if a requester promises you a bonus but doesn't pay you, there's really little recourse for you as a worker. Something is broken, maybe you go through that 10-minute survey. Not that that one is broken, but maybe it is, right? And it doesn't break until the very last submit button. You're kind of just out your 10 minutes. And so it's kind of fighting through some of that. So it probably won't work perfectly for you. There'll be probably some problem, and that's part of why you're doing this, to get some experience with that. Yeah, so there we go. I just used class time to earn 25 cents. Let's see, anything else I could, you can then see, you can see, oh shoot, where do I go? Oh no, my account, I think. You can see various things about, what you've done. So today I have submitted one job worth 25 cents. My lifetime, I think I've earned $50. Doesn't sound like a lot, but that's 25 times more than what I've asked you to do. And see these 5 hits that were rejected? That was when I gave out access to my account before I figured out how to get everyone approved for mechanical turks. All right, so why don't we just go ahead and end there, and unless there's any questions, I'll take a look at the, please do try to sign up for Mechanical Turk, and I'll forward the list that we got from the quizzes to the guy at Amazon who is supposed to be able to approve all of you, so you should just either get approved or we'll fix it when you don't get approved. All right, thanks. I'll see you on Monday. No. Right. Wednesday. I'll see you next Wednesday. That's right. Labor Day.